I received this USB for data recovery, and all it had is the broken header. And I tried repairing it, I got the connection, I checked all the voltages, but unfortunately it wasn't working. And I tried everything. The light would come on and that would be it. So what am I to do? I also tried looking up the most common faults, which is this resistor. You can replace them, you can do some other things with it, but unfortunately that wasn't it. So I had no other option but to find an identical donor, which is this one right here on eBay, and swap the chips. Now you would think, why wouldn't I just remove the chip and do a data recovery that way? But unfortunately this chip is encrypted. These particular USB drives from SanDisk, they're encrypted, so you can't just read the USB, so data is not recoverable unless you can fix it. What was amazing is I found the actual USB on eBay and it was brand new in a package. Here it is, 1 gigabyte. I wasn't sure if it's gonna be the right match. I had a bunch of these actually laying around, but they're all not matched. There was some difference in them, so yeah, here it is. And it even came with a Skype code. If anybody wants the code, you can copy it from this video. You get free voicemail and some other BS. So here's the code. First come, first serve. You can grab the code. So let's prepare this job. We're gonna grab the donor first, and we're gonna remove the controller and the NAND. We don't need that. We just need the actual PCB from the donor. So we're gonna get it ready here. I'm gonna use Chip Quick to kind of use this low melt solder, so we don't have to use a heat gun on this. Or if we have to use a heat gun, we're gonna use it on a very low heat. I don't want to damage this donor. I mean, they're pretty good. These boards are pretty resilient to heat, but I don't want to take risk and add unnecessary heat to it. After removing the NAND, we're gonna clean it up a little bit and flip the board over, and then we can start working on the controller. Same idea, just this chip's got legs on all 4 sides, so we're gonna use a heat gun here to lift it off once we added the Chip Quick. And that's it, the donor is prepped. And now that we have a good donor, we can get to the patient USB, and we're gonna remove the NAND and the controller so we can transplant it into this clean donor. And working on our patient USB, it's the same idea. We just have to be more careful, less heat if possible. We're gonna remove the controller, we're gonna remove the NAND, and the only difference here, we're gonna have to clean up the NAND and the controller just so the legs are ready to accept new solder, and then we can put it on the donor USB drive. So the cleaning takes a bit longer. I took my time with this. Obviously this is all sped up, but yeah, the process is pretty much the same. And when I was done, I had the donor board, and then I had the controller that was nicely cleaned up, and also had the NAND chip, and that's all we need for this particular USB to work. We need the controller and the NAND because, like I said, this chip is encrypted, so we need to decrypt it using the original controller. Also, it's important to take photos of the board from both sides because there are no markings on the board indicating which position the chip should be in. Like usually the board has a dot in the corner that matches the chip, but in this case there was no dot, so it's a good idea to take photos so at least you know where they go. And now that's all that's left, is to take our controller and take our NAND and prepare to attach it to the donor board. So we're just gonna do what we did earlier, but in reverse. We just gonna add some flux, we're gonna add some solder, we're gonna solder everything on and make sure that all the connections are there. I also checked each leg with tweezers to make sure that they're not moving, fixed what had to be fixed, and that was it. And once I was done, I did a final cleanup here on both sides, remove all the flux. It's not necessary, but might as well clean it so it looks nice and clean. And then we're gonna plug it in and see if it works. And I'm gonna plug it into Linux because in Linux I have a specific log running where I can see everything that's happening with the USB. So I like to plug it into Linux for that reason. I could plug it into Gardonix or to a USB stabilizer too, but I prefer Linux because I can see that log. And we got lights, but that doesn't mean it works. And here it showed up, the whole 1 gig USB SanDisk Cruiser encrypted. Now it works. We're just gonna copy the data for the client, and that's gonna be it. So that's it for this case. Luckily the swap worked. I didn't think it was going to work because I repaired the original USB and it wasn't working. The light was coming on and it wasn't any of the most common faults, the other ones I mentioned at the beginning of the video. Luckily this worked. There was only 63 megabytes of data, just a few documents, I don't know, maybe 100 or something, but they were important to my client. Anyway, that's it for this video, and I'll see you in the next video.